All right, let's get right into it. Have you ever really thought about what's going on inside your phone or their laptop? I mean, it is a whole bustling city of tiny, tiny components, and today we're going to pull back the curtain on one of its most important, yet kind of unsung, heroes. So, picture this. You plug your phone in to charge, and the power flickers for just a second. A surge. What is the one thing standing between your very expensive gadget and, a sad little puff of smoke? It's a great question, right? And the answer is this tiny marvel of engineering.
Because here's the deal. The circuits inside our modern devices are incredibly sensitive. They need a perfectly steady, stable diet of electricity. Any unstable voltage, even for just a millisecond, is a silent threat that can cause some serious game-over level damage.
And that brings us to our hero for today, the Zener Diode. It really might not look like much, but this little guy is a dedicated guardian, specifically designed to stand watch against the dangers of that unstable voltage.
Now, if you look at it, its design kind of gives you a hint about what it does. Down on the bottom, that's what it looks like in real life, just a simple little component. But look up at the top, that's its schematic symbol. See that zigzag? That Z-shaped line? Yeah, that's not just for looks. It's a huge clue to its very unique superpower. So, what exactly is this superpower? Well, it's something called the reverse breakdown. And to really get why that's so special, we first need to look at how it's different from its much more common cousin, the standard diode.
Okay, so a standard diode is basically a one-way street for electricity. Its whole job is to let current flow forward and block it from going backward. That's it. Simple. But a Zener diode? Oh, it has this amazing trick up its sleeve. It's specifically engineered to not only allow, but to safely conduct electricity in reverse. But, and this is the key, only under very specific conditions.
The best way to think of a Zener diode is like a precision pressure relief valve. As that reverse voltage starts to build up, nothing happens, nothing, until it hits a very specific point. See this sharp drop-off on the graph? That's the Zener breakdown region. The moment the voltage hits that point, bam, the valve opens and the diode lets all that excess current flow safely backward, protecting everything else in the circuit. And that super important trigger point, it has a name. It's called the Zener voltage, or VZ for short. Every single Zener diode is made with a very, very precise Zener voltage. It could be 5.1 volts, it could be 12 volts, you name it. This isn't some random failure. It's a predictable, repeatable, and literally circuit-saving feature. So how in the world does it get this precise ability? Well, like any good superhero, it's got an origin story, and it all comes down to a process called doping. It all starts with a simple base of silicon. Then they add impurities, that's the doping part, to create two different layers, a p-type and an n-type. But here's the secret sauce. Zener diodes get heavy doping. That means a much, much higher concentration of these impurities gets packed in. And this intense process forces the boundary between those two layers, the junction, to become incredibly thin and perfectly defined. And that super thin junction, well, that's everything. That's what allows for the Zener effect, that precise reverse breakdown, to happen safely, over and over and over again, without the diode just destroying itself. It's really engineered to fail perfectly. So now that we know its secret origin, where do we actually find this tiny guardian in the real world? The answer is, well, it's pretty much everywhere. You'd be amazed. Their number one job is acting as voltage regulators, providing a rock-solid, stable reference voltage for sensitive chips. They're also surge suppressors, like a bodyguard that jumps in front of a sudden voltage spike to take the hit. They can even be used as waveform clippers, where they literally shave the peaks and valleys off an electrical signal to clean it up at a really precise level. They are the silent protectors in so many of our gadgets. So what's the big takeaway here? What should you remember about all this? It's that the Zener diode is so much more than just a component. It's a whole philosophy of precision control built into a tiny little piece of silicon. You know, the source material just sums it up perfectly. While a normal diode is a one-way valve, a Zener diode completely transforms itself under pressure. It becomes a benchmark, a stable reference point that the rest of the circuit can totally rely on. So yeah, the next time you plug in your phone or fire up your computer, just remember what's inside. There's a tiny, elegant component working as a precision safety valve, making sure everything runs smoothly and safely just for you. It really makes you wonder, doesn't it? If a component this small can be this clever, this well designed, what other unsung heroes are hiding in plain sight, quietly making our entire digital world possible.